Hello guys, this is Himanshu from Code Campaign and we are continuing with our binary tree module. So the problem today we are going to discuss is left and the right view of the binary tree. Okay, so for to understand this video, what I would suggest is you go back and watch the level order traversal video first and then come back to this video. So that will help you to understand this video better. Okay, so let's proceed and understand what is the left view and the right view of the binary tree. So the left view of the binary tree is, as you have seen in the previous video where we discussed the top and the bottom view of the binary tree. So in the left view of the binary, in the top view of the binary tree, what we were doing, we were seeing the tree from the top. In the bottom view, we were seeing the tree from the bottom. And so same in the left view of the binary tree, we will see the tree from the left side. And in the right view of the binary tree, we will see the tree from the right side. So let's write the left view of the binary tree. So what will be the left view of the binary tree? So if we see the tree from this side, what nodes we will see? We will see this node, we will see this node, we will see this node. All these nodes will be hidden behind this. This will be hidden behind this, and we will see this node, right? So our left view of the binary tree will be 1, 2, 4, 8, right? So this is our left view. What will be our right view? Right view will be if we see from this side. So let me just erase. Hmm, okay. So what will be the right view? So we will be able to see this, 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 and this, right? So the right view of the binary tree will be 1, 3, 7, and 8. And how we are writing it? We are going from the level to level. So this is level 1, this is level 2, right? This is level 2, this is level 1, this is level 3, this is level 4. So we are writing from level 1 to level 4. So on level 1 we have 1, on the level 2 we can so um, in the right view on the level 1 we have 1, on level 2 we have 3, on level 3 we have 7, and level 4 we have 8. And the left view we had on level 1 1, on level 2 2, on level 3 4, and level 4 8. Okay, so this is how the left view and the right view of the binary tree will look like. Okay, now let's discuss one more example to understand it better. So let's pause the video here and write what is the left view of the binary tree. I would suggest you pause the video here and write yourself what will be the left view of the binary tree. So the left view of the binary tree will be 1, 2, 4, 8, 11, and 12. And what will be the right view? So let's erase it again. Okay, so what will be the right view? So from right we can see this, we can see this, we can see this one, we can see this one, we can see this one as well, and we can see this one as well. So the right view will be 1, 3, 7, 9, 11, and 12. So So this will be the right view. And these are very famous question that is being asked in Amazon and Microsoft interviews. Google also asks these kind of questions, but they twist it a little bit, so you will not be able to understand it clearly. They will not ask you to print the left view of the binary tree or the right view of the binary tree straightforward way. They will give you a problem which will in turn use this, right? But Amazon and Microsoft, they will directly ask you to write the left view of the binary tree, right view of the binary tree. So, okay. So I hope now you understood how to print the left view of the binary, right view of the binary. Now we have to understand how we are going to solve this problem, how we are going to write the algorithm for this. So let's move forward. So let's first discuss how we are going to write the right view of the binary tree. So let me change the pointer. Okay. So as you guys, if you guys see it closely, let me help you. So this is our level 1, this is our level 2, this is level 3, and this is level 4. Let's write the level order traversal for this. So on level 1 we have 1, on level 2 we have 2, 3, on level 3 we have 4, 5, 6, 7, on level 4 we have 8. Okay, so what will be the right view for this binary tree? Let's write the output here. So if we see from this side, if we see from this side, what we'll see? We'll see 1, 3, 7, and 8. And if you see in this sequence, this is our right view of the binary tree. Okay, so I will write right view. Now let's also write the left view of the binary tree. So what is the left view? 1, 2, 4, and 8. And let me change again the color of the pointer. Let's pick something different this time, yellow. So what is the left view in this sequence? This is the left view. So if you remember our level order traversal, so for printing the right view of the binary tree, what we have to do, we have to print the last elements, or we have to print the last elements on each and every level. So uh, so on this level we have only one, so this will be the first or the last element, so we'll print one. On this level we have the last element as 3, so we'll print this. On this level we have the last element 7, so we'll print this. On this level we have only one element, so this will be the first and the last, so this is 8. And to print the left view of the binary tree, we have to print the first element. So on this level, the first element is only one element, so this will be the first or the last, so we'll print this, right? And then on this level, this is the first element, so we're printing this. On this level, this is the first element. On this level, this is the only element, so this will be the first element. So if we'll be able to uh, write the level order traversal, and if we print all the first element or all the last element, we'll be able to find the left view or the right view of the binary tree. Okay, so so if you haven't watched the video for the level order traversal, I will highly recommend you go back, watch that video, and then come back to this video, because in the coding part we are going to write the same code uh, which we wrote for the level order traversal. The only thing that we are going to do is a little bit or slight modification in there, and we'll be done with the left view and the right view of the binary tree. So if you've been following my series so far, now you will be able to relate that all the problems are related to each other. So if you understand 2 or 3 traversal of the problem completely, you will be able to derive your solution for the other problems from those problems. This is the trick that you should be using in your interviews as well. So whenever you are being asked with a new problem, you should you should recap in your mind how many problems have you solved for that particular data structure, and then you have to try to derive the solution from those problems for this new problem that is being asked. Okay, so so let's recap on. Let me erase this first. So okay, so now let's. So if you know already watched the level order traversal, you know that what we do in level order traversal, we use queue. So this is our queue data structure that we are going to use, right? And so, and what we'll do here, we will take one count element as well. Let me change the color. This is very bright. Oh, okay. So let me change the color. Cool. So okay, so we'll take one more count variable where we'll keep the snapshot of the number of nodes which are present on a particular level. So we'll see how we are going to do it. So we'll start from there, from 1. So what we'll do initially, we'll push the 1 into the queue. Okay, and right now, first let's start with the solution for the right view of the binary tree. So first we'll discuss the right view of the binary tree. Okay, so after pushing the element, what we'll do, we will take the count of the queue. So number of elements present into the queue, and we'll store it here. So right now only one element is present, so we'll store it here. Okay. So after this, what we'll do, uh, after this, we will pop the element from the queue. So let's pop one from the queue. Okay. Let's pop one from the queue. Now what we'll do, we'll decrement count. Okay. So decrement the count. So if we decrement the count will become 0. Okay. And whenever our count will be 0, so if count equal to 0, we will print the value. So we'll print the value of the node. So so after decrementing, so initially our count was 1. After decrementing it 0, so what we'll do, we'll print the value of the node, which is 1. Okay. So we'll print the value of the node. So let me write here print value of node. Okay. So we'll print the value of the node, which is 1. Okay. And after this, what we used to do in level order traversal, we used to push the elements or the childrens of the node. So we'll push 2 and 3 into our queue. Okay. Now after this, what we'll do, we will again reset our count to the number of elements into the queue. So our count will become what this time? Now we have 2 elements in the queue, so our count will become 2. Then we'll pop the first element from the queue. So we'll pop 2 from the queue. After popping 2 from the queue, we will decrement the count. So now our count will become 1. Now what we'll do, we'll push the elements of the queue. We will push the element of the or the children of the 2 into the queue. So the left children is 4, so we'll push 4, and right children is 5, so we'll push 5 here. Okay, now our count is not 0, so we'll not print any value here. We'll again go back, and then we'll pop the next element from the queue. So we'll pop 3 out of the queue. Okay, now we'll again decrement our counter, so this will become 0. So as our count is 0, we'll go ahead and print the value of node, which is 3. Okay, now again what we'll do, we'll push the children of 3 into the queue. So children of 3 are 6 and 7. So now our count is again 0. So what we'll do, we'll again recapture the number of elements into the queue. So now number of elements into the queue are 4. So our count will become 4. Now again we will pop the element from the queue, which is 4. We will decrement our counter by 1. So this will become 3. Now our count is not 0. So we will not do anything. After this, what we'll do, we'll see if if 4 has any children that we can push into the queue. 4 do not have anything, so we'll leave 4. Now again we'll pop the next element, which is 5. We will again decrement our counter, so our counter will become 2. So counter is not equal to 0, so we'll not print anything. We will now check if 5 has any children that we can push into the queue. So 5 do not have any children that we can push into the queue, so we'll not do anything. Now we'll pop another element, which is 6. Our counter will become 1. As our counter is not 0, we'll not do anything. We'll check if 6 has any element that we can push into the queue. So 6 has left element as 0, but the right child is 8. So we can push 8 into the queue. So we'll push 8 into the queue. After this, we'll pop 7 from the queue. We'll decrement our counter. Now our counter is 0. So we'll print the value of the node, which is 7. Now we'll check if 7 has any children that we can push into the queue. So left and the right, both children of 7 are null, so we cannot push anything into the queue. Now we will now again what we'll do, we will, as our counter value is 0, we will again take the we will again make our count equal to the number of element present into the queue. So only 8 is present into the queue, so our count will become 1. Now we'll pop the element from the queue, which is 8. We'll pop it. Now we will decrement our counter, so this will become 0. Now our count is equal to 0. So now our count is equal to 0, so we'll print the value of the node, so this will be 8. So now our count is 0, and our queue is also empty. That means this will be the output. And if you see, this is our right view of the tree. Okay, so that's how we can implement the right view of the tree. Now if we need to print the left view of the tree, what change we have to do? The only change we have to do here, we have to put instead of 0, we have to put if, let me okay. So instead of this condition, we have to change this condition to if count equal to q dot count. Oh, let me erase this and write it in a proper manner. So let me start from if count equals to q dot count, right? Then we'll print the value. So so only this change we have to make. So in this case, when our count will be equal to the q of count, so what we were doing, we were whenever our count will becoming 0, we were again resetting it, or we will again resetting it with the number of elements into the queue. So at the start only, our count will be equal to the q dot count. Okay, so what we have so the only difference is here we were printing the last element. That's why we were waiting for count to become 0. But in this case, we have to print the first element, right? So that's why we are saying when count is equal to the q down count, then we'll print the value of the node. If you're not understanding it, just wait for few minutes. You will understand it when we'll write the code in the next sequence. I hope now you guys understood how you can go ahead and implement the left view and the right view of the tree. So now let's go ahead and write the code for this. Okay, so this is where we left our ID in the last video. So where we wrote the bottom view of the binary tree, right? So now let's go ahead and write the code for the left view of the binary tree. Okay, so let's copy the level order traversal. So let's utilize whatever hard work we did in our previous videos. So copying the code for the level order traversal. And now you will see we have to make just a very little change and our level order traversal will start printing the left view of the binary tree. So let's rename this function first. Left view of binary tree. Now what we have to do here, let's take one more variable. We will say queue count. Let's put our queue count in this. And now what we have to do here, for the left view, what we have to do, we have to print the first element. So what we have to do, we have to say whenever count equal to queue count, then only print the value of the node, right? So our count will be equal to queue count when we will take the first element out of the queue, right? On any level. So on this level, the count will be 1 for the queue. So because there is only one element on this level, it will be 2, and on this level it will be 4, right? So for printing the left view of the tree, what we have to say? We have to say when count equal to queue count, right? So this is what we are doing here. Now let's comment this new line as well. Okay, so now let's go ahead and run our program. Left view of the binary tree. Let's see if it will run on. Okay, so let's go back to our, let's bring this down. Okay, now let's compare. So the left view will be 1, 2, 4 and 8. So our left view is 1, 2, 4 and 8, right? We can even go back here and let's bring our slide here. So the left view is 1, 2, 4, 8, which is 1, 2, 4, 8, same. Okay, now let's go back into our ID and write the code for the right view of the binary tree as well. So in the right view of the binary tree, what we have to do, we will print the element first. We have to stop debugging. So let's change this code to right view of binary tree. I copy pasted the, okay, there is some problem. Okay, I have to copy this. So I'm copying the left view of the binary tree. So I think it's the code. Now just change it to right view of the binary tree. And the only change that you have to make here is instead of this, it should be 1, right? So if you see here, uh, let's go back to our slide. Okay, so here what I said the count is equal to 0, so it should be 1 because when the count will be 0, it means there is no element, right? But we want to print the last element, right? So when the count is 1, then we'll print the value of the node. Okay, so let's come here. So so when the count is 1, then we are printing the value of the node, right? So let's go ahead and run our code. So let's comment the left view, now print the right view. So this is our right view of the binary tree. Let's compare it with the output that we wrote in the. So yeah, 1378, 1378. So this is our right view of the binary tree. Now let's discuss the time complexity of this algorithm. So the time complexity, if you already seen the level order traversal video, you already know the time complexity of the algorithm is O of n, because we have to explore all the elements. For this algorithm also we are exploring all the elements, so the time complexity will remain as On, and the space complexity will be equal to the size of the elements that we have to store into the queue. So in worst case scenario, we have to store all the elements into the queue. So the space complexity will also be O of n. Okay guys, now I hope you understood how to write the left view of the binary tree or the right view of the binary tree. If you haven't subscribed to my channel, please go ahead and subscribe to my channel. If you like this video, please go ahead and give it a thumbs up. And if you have any query, please put it into the comment box. Thank you for watching my video.